This is my trigonometry course. Today we're going to continue to learn how to solve trigonometric equations. If you haven't done the homework completely and correctly from last class, do that homework before watching this video. So now we're going to solve equations resembling the quadratic form, but this really doesn't look like a quadratic equation. It doesn't look like anything resembling a quadratic because we have two different trigonometric functions. And by the way, technically these are not quadratic equations, they're just equations resembling the quadratic form, and we're going to use the techniques we learned when solving quadratics to solve these equations. So the first thing we need to do is to convert the secant squared expression into a tangent expression so that we have the same trigonometric function on both sides of the equation. So remember, secant squared theta is equal to 1 plus, actually it's equal to tangent squared plus 1. So that was a Pythagorean identity. And again, we're going to use the techniques we learned when solving quadratics to solve this. So we're going to put everything on the left side of the equation. And why the left side? Well, because we want a positive coefficient on the tangent squared theta term. So I'm going to add 4 tangent theta to both sides. Then I'm going to add 2 to both sides. And now we have something that resembles a quadratic expression because we have some algebraic expression squared, or trigonometric expression squared, and then we have a trigonometric expression that is not squared, and then we have a number that has no trigonometric expression. So it might be easier for you to see if we let x equal tangent theta. You don't have to do that. But so now we get x squared plus 4x plus 3 is equal to 0. And it just so happens that we can factor this expression. Sometimes we cannot factor, but this time we can. So we put 2 x's because we have x squared, so these two variables have to multiply to x squared. And then we're going to ask, what are two numbers that multiply to 3 and add up to 4? If you multiply two numbers, you get 3, and you add those two numbers, you get 4. What are those numbers? Well, if you said 1 and 3, you're correct. What this tells us is that x must be equal to -1, or x must be equal to -3. Because if you have a product of two expressions, a product that equals 0, that means that one of the expressions must be 0 or the other expression must be 0. That's the only way that the equation would work. So we show that x has to be -1 or x has to be -3. But remember, x is equal to this expression up here, tangent theta. We're not looking for x, we're looking for tangent theta. So we're going to replace x with tangent theta. And now we're solving these equations down here that solve one at a time. So you may recognize this as -x over x. So that's a 45, 45, 90 triangle. We don't need a calculator for that. And it's negative, which means that our solutions have to be in the second quadrant or the fourth quadrant. And again, the reference angle is 45. So in both these triangles, the reference angles are 45. And the first solution is 135 degrees, and the second solution is 315 degrees. And we're looking for the solutions between 0 and 360. So theta is equal to 135 degrees and 315 degrees. Now over here, we cannot do this without a calculator. So you want to get your calculator out. If you're using a graphing calculator, you're going to push the, well, if you have a TI-84 Plus, the most popular graphing calculator, you're going to push the blue second button, and then the tangent -1 button, the blue tangent -1 button at the middle right. Now I said tangent -1, but that's really not what it's called. It's called tangent inverse. That's the proper word there. So we're going to find tangent inverse of -3. So the blue second button, the tangent inverse button that's next to the tan button, well, that is the tan button, and they're going to enter -3 and press enter. If you're using an iPhone, then you enter -3 first, then you push second upper left, and then the tangent -1 button, tangent inverse. And we get -71.57 roughly degrees if we round to the nearest hundredth place. Now this is not a solution, but that tells us the reference angle. So now we can go over here, and if tangent is negative, again, our triangles have to be in the second quadrant and the fourth quadrant. But the reference angle is 71.57. And you can draw a lot of different pictures, but you only really need one set of axes. So we have one solution that is whatever that angle is. So we're going to subtract 71.57 from 180, and we get 108.43 degrees. So I'm going to move this over and write 108.43 degrees. And now we're going to subtract 71.565 from 360, and we get 288.44 roughly. So probably should write the angles in ascending order just to be orderly. So 288.44 degrees roughly. Okay, so those are all the solutions between 0 and 360. So you can see that that problem was a little more challenging. We had to use a Pythagorean identity, and we had to use our knowledge of quadratic equations to factor, and we had to use our knowledge of trigonometric expressions with angle measures greater than 90, and so on and so forth. Special triangles, on and on and on. So there's a lot going on here. Now, if you're having trouble with some of this stuff, then you can go back to my previous classes. Remember, you got to do all that homework and do all the problems in class that we do together. Okay, let's try number 2. Let's try one more of these before you try one on your own. So we have a big problem because we have a cotangent function, a sine function, and a cosecant function, and how are we going to solve this? Well, we'll try to simplify the equation. I'm going to change cosecant b to 1 over sine b. And I'm going to change cotangent to cosine b over sine b. So that is a ratio identity. And this over here was a reciprocal identity. And now I'm going to multiply both sides of the equation by sine b. There's different ways that you can do this, but probably the fastest way is just to multiply both sides by sine b. And why am I going to do that? Well, because that is going to get rid of the fraction. We don't like that fraction. So I'm going to multiply this side by sine b, and the other side by sine b. And that's going to cancel out the sine b's on the left side of the equation, so we're just left with 10. And then it's very important to use distribution. You must use distribution. You're going to use multiply sine b times 3 sine b to get 3 sine squared b. And you're going to multiply sine b times all of this, and the sines are going to cancel out, and that's the whole reason that we did that. So we get 10 cosine b. Okay, so let's look this over, make sure we did everything correctly. Looks like we did. But we still have a problem. The equation is simpler in the sense that we only have 2 trigonometric functions as opposed to 3. But we still have different functions. But that's okay, because remember, we learned a relation between sine and cosine. Remember, sine squared b plus cosine squared b is equal to 1. Now we have not, we've used the Pythagorean identities in previous classes, but we didn't really manipulate this equation. You can manipulate these identities any way you want to help you solve problems. So this may be a little unfamiliar to you, but that's okay. We're going to solve for sine squared. I'm going to subtract cosine squared from both sides. I'm going to subtract cosine squared from both sides. So then I get sine squared is equal to 1 minus cosine squared b. Okay, so now I'm going to take this, which is equal to sine squared b, and I'm going to plug it in for that. Now again, this may seem a little strange. We haven't done it like that before, but that's okay. All we're doing is just manipulating this equation. We can change the form of that equation. It's okay. In fact, you're going to be required to do that quite a bit in the trigonometry curriculum. Okay, so now we have to use distribution. Let's multiply 3 by 1 and 3 by cosine squared b. And we get 10 is equal to 3 minus 3 cosine squared b plus 10 cosine b. And now you can see again we're going to have something resembling a quadratic equation. So I want a positive coefficient on my cosine squared term, so I'm going to add 3 cosine squared b to both sides. And I'm going to subtract 10 cosine b from both sides. And I'm going to subtract 3 from both sides. And there you go. So I probably should have reminded you that the reason that we put everything on the left side of the equation is because we cannot solve a quadratic expression or quadratic equation or anything resembling a quadratic equation unless we put it in standard form. So now that it's in standard form, we can try to factor this, but before we do that, let's try to simplify a little bit. Let's let x equal cosine b. Then we have 3x squared minus 10x plus 7 is equal to 0. And let's see if we can factor this. We don't really know if we can factor it or not. So 3x times x is 3x squared. And we have to ask, what are two numbers that multiply to 7? Two numbers that multiply to 7. Now they're not going to add up to negative 10 because the coefficient here complicates things. But we do know that the inner terms have to add up to a negative, so that means that both of these numbers have to be negative, and of course the only option is 1 times 7. Okay, so now we need to use FOIL on this to see if we got the right answer. We don't know if we did it correctly or not. So FOIL, f of FOIL is 3x squared, O of FOIL is negative 21x, I of FOIL is negative x, and last term's 7. If you add these up, you get negative 22x. That didn't work. So let's try switching the term, or the numbers. Let's put the negative 7 first, and then the negative 1. So now let's do FOIL again. Multiplying the first terms, we get 3x squared. Outside terms, we get negative 3x. Inside terms, we get negative 7x. And last terms, we get positive 1. These add up to negative 10x, and that's what we're looking for. So it turns out we can factor this. That's good news. So what this tells us is that 3x minus 7 has to be 0, or x minus 1 has to be 0. If we solve for x, we get x is equal to 7/3, or x is equal to 1. So we found x. The problem is we don't want x. What we want is to isolate cosine b So we need to go back to cosine b. So x is equal to we can use an arrow because we're out of room. X is equal to 7/3, which means that cosine b is equal to 7/3. And x is equal to 1, which means that cosine b is equal to 1. Now we have good news here. The good news is that's not possible. It's not possible for cosine b to be 7/3 because 7/3 is bigger than 1. Now let's look at our graph. You see cosine, it goes back and forth between 1 and -1, 1 and -1. So it's never going to get to 7/3. 7/3 would be up here somewhere. So that's impossible. So we can just say cosine b is never going to be equal to 7/3. So not equal to 7/3. But cosine can be 1. So let's look at the angle when cosine is 1. We have 0 and 360 degrees. 0 and 360 degrees. But notice here that we're not allowing b to be 0 or 360, or at least we're not looking for the answers that are equal to 0 or 360. So b would be 0 degrees or 360, but we're not looking for those answers, so we can just say no solution. So the purpose of this problem is to show you that you really need to follow the directions. If they say find the angle between 0 and 360 but not equal to 0 or 360, then you really got to make sure that you pay attention to that. Now, you're still going to need to do a problem like this, so that was good practice. Remember, sometimes equations have no solution. So I want you to try number 3, and you can use number 1 to help you. I'm going to give you a hint. Remember, this is a Pythagorean identity. You don't have to do any manipulation. You can just use your Pythagorean identities. So go ahead and try number 3. You want to convert everything in that equation to the cosecant function, and then you want to put everything on one side and solve what resembles a quadratic equation. So try number 3. When you come back, we'll do it together. Okay, we're back. So as I said, cotangent squared plus 1 is equal to cosecant squared. That was a Pythagorean identity. we want the coefficient of the squared term to be positive, so I'm going to leave this cosecant squared omega on the right side of the equation, and I'm going to subtract 3 cosecant omega from both sides of the equation. And I'm going to subtract 2 from both sides of the equation. So we put everything on the right side of the equation. And this resembles a quadratic equation, so let's let x equal cosecant omega just so we can see exactly what's happening here. So we have 2x squared plus 3x minus 2, and we're going to factor that. So hopefully we can factor this. 2x times x is 2x squared. And what are two numbers that multiply to negative 2? They're not going to add up to 3 because the 2 here complicates things, but what are two numbers such that if you multiply them you get negative 2? So I'm just going to try negative 2 and positive 1. And so now I want you to be aware that you don't have to do the entire FOIL algorithm. You can just do the outside terms. We get negative 4x. And the inside terms, x. So add those up and you get negative 3x. So we got the right number, it's just the wrong sign. So that's good. That means all we have to do is just change the sign. So I'll change that to a negative and change this to a positive. Okay, so what this means is that 2x minus 1 has to be equal to 0, or x plus 2 has to be equal to 0. So x is equal to 1/2, or x is equal to negative 2. But we don't want to know what x is. We want to know what cosecant omega is. We let cosecant omega be cosecant. So we're going to change x back to cosecant omega. Now, this may have thrown you kind of for a loop there. This looks like a recognizable ratio. It is a ratio that we recognize, but sine can be equal to 1/2 and cosine can be equal to 1/2, but cosecant cannot be equal to 1/2. So if you were confused about that, sorry about that curveball. But if you look at your cosecant curve, 1/2 is this line here. You can see that there's no red curve that goes through that line. So it's impossible for cosecant to be 1/2 or anything below 1, or really anything between 1 or negative 1. So that's impossible. So we say cosecant is not equal to 1/2, but you may have recognized this ratio as negative 2x over x. So that is a recognizable ratio. So if cosecant is negative, then we have a triangle in the third quadrant and a triangle in the fourth quadrant. And if we have 2x over x, that means the opposite side, because cosecant is the hypotenuse over the opposite side, so the opposite side must be x, and hypotenuse is 2x, of course. And we don't really need the other side, but the other side would be x root 3. And the reference angle has to be whatever angle is always opposite x, which of course is 30 degrees. So this angle here is 210 degrees, and this angle over here is 330 degrees. So it looks like those are our solutions. Omega is 210 degrees or 330 degrees. So if you got that one right, perfect. If you had a few problems, that's okay. This is a pretty complicated problem, as you can see, so if you got stuck along the way, that's okay. Now you see how to do it. Okay, I want you to try number 4. Get a picture of number 2 to help you. Be aware that there's going to be an extraneous solution, meaning when you plug the solution back into the original equation, you're going to get an undefined expression. Also be aware that you're going to need a calculator. So try number 4, and when you come back, we'll do it together. Okay, we're back. So first we're going to use a ratio identity. We're going to change tangent beta to sine beta over cosine beta. And we're going to use a reciprocal identity. We're going to change secant beta to 1 over cosine beta. And then we're going to multiply both sides of the equation by cosine beta. It's kind of what we did here, except in that case we multiplied by sine b. So I'm going to go ahead and show that. So I'm multiplying both sides of the equation by cosine beta. And you don't have to show this necessarily. You do have to show some work, but you don't have to show every step. I'm just showing this so there's no confusion. So let's double check, make sure we wrote everything correctly. Looks right. Now, when we multiply these, we're just going to get 1. And we're going to distribute the cosine beta to each one of these terms. And the cosine beta is going to cancel out here. We're just going to be left with negative sine beta. And cosine beta times 3 cosine beta is 3 cosine squared beta. And now we're going to use a Pythagorean identity. Remember, sine squared beta plus cosine squared beta is equal to 1, but we can subtract sine squared beta from both sides, and we see that cosine squared beta is equal to 1 minus sine squared beta, so that's just a different way to write that Pythagorean identity. So we're going to change that purple cosine squared beta to 1 minus sine squared beta. And the reason that we did that is now we have just the sine function, whereas here we had both the sine and the cosine function, so it was too complicated. So let's go ahead and multiply 3 using the distribution rule. And now we have what resembles a quadratic equation. We like the squared variable to be positive, so we're going to put everything on the right side of the equation. So I'm going to add 3 sine squared beta to both sides, and I'm going to add sine beta to both sides. And I'm going to subtract 3 from both sides. And to make things a little easier, we can let x equal sine beta, just so we can recognize this equation as quadratic form. So I replaced these sine betas with x's just to make it easier for us to see how to solve this. So sometimes you can factor this expression to solve it. Other times you'll have to use the quadratic formula. In the next problem we're actually going to use the quadratic formula because we won't be able to factor this. But in this case we can factor. So I'll write two sets of parentheses. And 3 times 1 is 3, so I'm going to try 3x and x. And what two numbers multiply to negative 2? Well, we could try maybe positive 1 and negative 2. But we have to check and make sure that that works. Now remember, when you have a number here, it complicates things. So you can't just ask what two numbers multiply to this and add up to 1. It's more complicated than that. We are going to ask what two numbers multiply to negative 2, but they're not necessarily going to add up to 1. So now let's use FOIL. 3x times x is 3x squared. We're going to check to make sure we factored properly using FOIL. 3x times negative 2 is negative 6x. 1 times x is x. And 1 times negative 2 is negative 2. Combine the inner terms and you get negative 5x, but we don't have negative 5x, so that didn't work. That's okay. All we have to do is switch the numbers, so let's put the 2 over here and the 1 over here. And then when we perform FOIL, we will get negative x, but we want positive x. That's okay. All we have to do is change the sign, so I'm going to put a negative there and a positive there. And so now if we FOIL, we'll see that we got the right answer. Or we factored correctly, I mean. So, by the way, I forgot to write zeros here. We should have 0 on the left side of the equation. So now we can say that 3x minus 2 is equal to 0, or x plus 1 is equal to 0. That's the only way that this equation could possibly work. If this factor is 0 or if this factor is 0, because when you multiply 0 by something you get 0. So now we're going to say x is equal to 2/3 or x is equal to negative 1. And remember, x is sine beta. We don't really want x, we want sine beta. So now we're going to have to change x back to sine beta. And now we're going to have to find beta. So let me see if I can find more room here. Okay, so we're going to go up here. Remember, when you run out of room, don't panic. So notice we have negative 1 here. When sine beta is 1, 0, or negative 1, that corresponds to a collapsed triangle. So whenever you have a collapsed triangle, you want to look at the corresponding curve. So we're looking for the points where the y value is 1, or excuse me, negative 1. And what angle does that correspond to? It corresponds to 270 degrees. This angle here. So beta is 270 degrees. And we also want to look at this value over here. This is where we need to use the calculator because that's not a recognizable ratio. So we have to get our calculators out, and we're going to enter, if you have an iPhone, you can enter 2 divided by 3 equals, push the second button at the upper left if you're in landscape mode, and then push the sine -1 button, also called the sine inverse button. If you're using a TI 84 Plus, you can press the blue button at the upper left, and then the sine button, and then 2 divided by 3, and then enter. And push the mode button and make sure you're in degrees. Then you can push the second blue button and then the mode button to quit out of that page. So we get 41.81 degrees, and sine can be positive 2/3 in the first quadrant, or it can be positive 2/3 in the second quadrant. So we can rotate all the way over here. So that's going to be 180 minus 41.81. So we get 138.1 degrees. And the pink angle is 41.81. Our possible solutions are 270 degrees, 41.81, and 138.1 degrees. Now when you plug this in, you're going to find that we're going to get 0 in the denominator. Cosine 270 degrees is actually 0, but you can't have 0 in these denominators here. So that's an extraneous solution, so we're going to write not equal to 270 degrees. But these solutions will work. It doesn't tell us what to round off to. We can use our own discretion. So if you got that right, excellent. So let's go on to the next problem. We're going to do 2 more of these types of problems. We're going to need a calculator on this problem. So we have 2 different trigonometric functions. So I'm going to convert the cosecant A function to 1 over sine A. And of course you recognize that as a reciprocal identity. And then I'm going to multiply both sides of the equation by sine A. And the reason I'm doing that is I want to get rid of that fraction. So we get 1 on the other side, and sine A times sine A is sine A squared, sine squared A that is. And sine A times 3 is 3 sine A. That was the distribution property. So now we see that this equation resembles a quadratic equation. So we're going to put everything on one side of the equation, because we can't solve this unless it's in standard form. And then I'm going to let x be sine A, and we have x squared plus 3x minus 1. Now if you try to factor this expression, you're going to find that we cannot do that easily. It's not an easily factored expression. So we're stuck. We can't do anything unless we use a very powerful tool that we learned in intermediate algebra. Sometimes this is covered in beginning algebra also. We know that x is always equal to, if we have a quadratic equation, x is always equal to negative b plus or minus root b squared minus 4ac all over 2a. And a is 1, b is 3, and c is negative 1. So just to be clear, one goes there, and 3 goes there, and let's see if we can get a different color. Negative 1 goes there. So just to be clear where all this goes. Okay, so we have negative 3 plus or minus root 3 squared minus 4 times 1 times negative 1. Make sure that's all under the root, over 2 times 1. So let's look over that, make sure we did that correctly. Everything looks right. So x is equal to negative 3 plus or minus, and you can do all that. So we have negative 4 times 1 is negative 4, negative 4 times negative 1 is positive 4, and 3 squared is 9, 9 plus 4 is 13. 2 times 1 is 2. I know I did that very quickly, but we don't really have a lot of room to show every single step. Okay, so we found x. X is equal to this expression. But we don't care about what x is equal to. We want to know what sine is equal to. X is equal to sine A. So we're going to let x be sine A. And now we have two equations, so I'm going to move up here. We're out of room, obviously. So sine A can be equal to negative 3 plus root 13 over 2, or sine A can be equal to negative 3 minus root 13 over 2. So I know it's kind of hard to fit this in on the page. So let's make sure we got that right. Looks correct. So obviously this is difficult to deal with, so we can use our calculator. I'm going to enter root 13 and push the equal button. And if you have a graphing calculator, you can do all of this at once. Plus negative 3, and then divided by 2. So sine A is approximately equal to 0.30277, and it just goes on and on. So before I get rid of that number in my calculator, I'm going to, on my graphing calculator, I'm going to press the blue second button, and then the sine inverse button, sine negative 1 button, and then I'm going to push the blue second button again, and at the bottom right I'm going to push the negative button with parentheses, because that says A and S, answer, and that puts my previous number right into my calculator. I'm going to push enter, and I get 17.6 degrees approximately. Maybe we can say 6.2. So I did a lot in the calculator there. You can do it however you want to, but if you push the blue second button with the TI-84 plus, and then push the answer button at the bottom right, that has it's the white button with the negative symbol with parentheses, you can put that number right into your sine function. So I should probably show that. So A is approximately equal to sine inverse of that number. So you want to enter this in your calculator. If you have an iPhone, you're going to enter this number first, and then you're going to push the sine inverse button. And make sure that you're in degree mode. If you're not in degree mode, push the mode button at the upper left and change to degrees. Okay, so that is one solution, but we have another solution in the second quadrant. That's the first quadrant solution. The reference angle is 17.62, so I'm going to subtract that from 180 to get the other solution. And the other solution would be 162.338 degrees. I'll round off. Okay, so now we need to deal with this situation up here. Let's see what we get. So I'm going to enter root 13 equals, and I'm going to times that by -1, make sure it's a negative, or you can just push the plus minus button on your iPhone. Then I'm going to add that to -3, and then I'm going to divide by 2, and I get -3.3 approximately. So sine is approximately equal to -3.3, but that's not possible. We can't have a sine value that's approximately equal to -3.3. Remember, sine is between -1 and 1 inclusive. It can't be less than -1 or bigger than 1. Okay, so it looks like we have our two solutions. So A is approximately equal to 17.62 degrees and 162.38 degrees. So that was a very challenging problem, but that's okay. You can do it. Try number 6. If you get stuck, that's okay. But try number 6, and when you come back, we'll do it together. Okay, we're back. So I'm going to change secant to 1 over cosine alpha. So we used a reciprocal identity. And then I'm going to multiply both sides of the equation by cosine alpha. And we get 2 cosine squared alpha. And we can distribute. So cosine alpha times 1 over cosine alpha is 1. And cosine alpha times -2 is -2 cosine alpha. So now I'm going to add 2 cosine alpha to both sides and subtract 1 from both sides. And let's let x equal cosine alpha to make things easier to see. So we have 2x squared plus 2x minus 1. Now when you try to solve this, you're going to find that this equation this expression is not factorable. It's not easily factored, that is. So we have to use a quadratic equation, or the quadratic formula, that is. So just to remind you of what that formula is, I'm going to write that. And this number here goes there, and this number goes there, and this number goes there. Whoops, that's not 4. The A is going to be blue. Sorry about that. Okay, so we're ready to go. I'm going to plug in all the numbers. B is 2, and A is 2, and C is -1. Okay, so we have -2 plus or minus. Let's do this together. -4 times 2 is -8. -8 times 1 is +8. +8 plus 4 is 12. And 2 times 2 is 4. So we have -2 plus or minus. This is 4 times 3. The 4 comes out as a 2. And we're out of room. That's okay. We can use an arrow and go up. So x is equal to negative 1. We're going to reduce that fraction so we can divide everything by 2. So we get negative 1 plus or minus root 3. Negative 1 plus or minus root 3 over 2. So that's what x is equal to. We figured out what x is equal to. Problem is we don't want x. We want cosine alpha down here. Remember, we let cosine alpha equal x temporarily. So now we're going to change back to cosine alpha. And let's use our calculator to figure out what those values would be. And by the way, let's go ahead and separate. So what this means is that one possibility is that cosine alpha is equal to negative 1 plus root 3 over 2. And the other possibility is that cosine alpha equals negative 1 minus root 3 over 2. So square root 3 equals, and then plus negative 1 equals, and then divided by 2 equals, and we get cosine alpha is approximately equal to 0.366. And let's calculate the other value. So root 3, then times negative 1 to make it negative, and plus negative 1, and then divided by 2. And we get negative 1.366. But remember, cosine has to be between 1 and negative 1, or equal to 1 or negative 1. It cannot be smaller than negative 1 or bigger than positive 1. So remember, did I say, yeah, cosine. So cosine cannot be smaller than negative 1 down here. So that equation does not produce a solution. So we can say approximately not equal to negative 1.366. We're going to need the calculator to find alpha over here. Alpha is going to be cosine inverse of 0.366. So you want to push the blue second button and then the cosine negative 1 button, in other words cosine inverse. And if you lost that number in your calculator, you can recalculate. We got 0.366025408. I can push the blue second button and then cosine inverse, cosine negative 1, and then I can push the blue second button. At the bottom right, I can push the answer button, the negative 1 button in parentheses. That's the answer button, and I can put that right into the function and press enter. Again, you can do it however you want to, but that's the fastest way to do it on a TI-84 Plus, the most popular graphing calculator out there. So we get 68.5 degrees approximately. Now, if cosine is positive, then our answers are going to be in the first quadrant, and the fourth quadrant. So this angle here is 68.5 degrees, and we need this angle here, and we can find that understanding that, again, the reference angle is 68.5. So we're going to subtract that 68.5 from 360, and we get 291.5 degrees, roughly. So, whoops, that shouldn't be A, that should be alpha. Sorry about that. So alpha is approximately equal to 68.5 degrees and 291 0.5 degrees. So if you got those right, excellent. Good job. Okay, so those are some examples of trigonometric equations where we have to use our knowledge of quadratic equations to solve. And now we're going to go to equations with half angle, double angle, and triple angle expressions. We have an equation here, but notice that there's something different. Instead of theta in the function, we have 2 theta. We haven't seen that yet. So what we're going to do is we're going to ignore this 2 theta. We're just going to ask, what angle do we plug into this function to produce this ratio? So you probably recognize that ratio as x root 3 over 2x, and sine is the opposite side opposite the reference angle divided by the hypotenuse. And if it's negative, our triangles are going to be in the second and fourth quadrants, and the reference angle has to be 60 degrees because the side opposite, this blue side, must be x root 3. And so the angles that we're looking for are 240 and 300. So we found the values that we plug in to the sine function to give us a negative root 3 over 2 ratio. The problem is we're not looking for the angle that we plug in to get this ratio. We're looking for a number such that when you multiply it by 2, you get the angles that will produce this ratio. What number multiplied by 2 will give you these numbers that will produce this ratio? So in order to show this on paper, we'll write 2 theta is equal to 240 degrees or 300 degrees. Now it's not really mathematically correct to write a list of numbers in an equation, but we're just doing this because it's the easiest way to show where we're going with this. So again, these are the numbers that you plug into the sine function to get this ratio. But we're not looking for those numbers. We're looking for the number that you multiply by 2 to get those numbers. So we're going to divide both sides of this equation by 2, and maybe I'll show that. So we're going to divide everything by 2, and so we get theta is equal to 120 degrees and 150 degrees. So there you go. There's only one problem. When you have theta multiplied by some whole number, oftentimes you're going to have more solutions than you think. If it's 2 theta, you're probably going to have roughly double the number of solutions in our typical interval here. So this is kind of a tricky problem. So what we do is we find more angles that will work in this equation. 240 works, 300 works, but let's find some coterminal angles. So let's add 360 to 240. Remember, that's how you find coterminal angles. If we rotate all the way around till we get back to where we started, that's a coterminal angle that will work in that equation. So if we add 360 to 240, we get 600 degrees. And let's add 360 to 300, then we get 660 degrees. So if we divide those numbers by 2, then we get 300, and we get 330 degrees. So these numbers are all between 0 and 360. Now, I know what you're thinking. You're thinking, why is he trying to trick me with this type of problem? Well, again, we're looking for the theta values between 0 and 360 that will work in this equation, and all of these values are between 0 and 360, and if you plug them in and multiply them by 2, you will get this ratio. So that's what we're doing here. Now, maybe to be safe, we should find one more coterminal angle, because you never know. There might be some more solutions. So let's add 360 to 600 to get another coterminal angle, and we get 960 degrees, and if we divide that by 2, 960 divided by 2 is 480. Now 480 is too big, so we know we can stop at that point. We don't need that. So the solutions are 120, 150, 300, and 330. So again, usually we only have 2 solutions between 0 and 360, but now we have 4. We had double the number of solutions because we had 2 theta in that equation. So let's try a couple more of these. So cotangent is equal to 1, so that's x over x. So we're dealing with a 45, 45, 90 triangle. And if it's equal to 1, then that means our triangles are in the first quadrant and the third quadrant. We know the reference angle is 45 degrees. So one angle that works is 45, but another angle is 225 degrees. So those are the angles, 45 and 225, that we plug in to the cotangent function to give us 1. But we're not looking for the numbers that we plug in to get 1. We're looking for the number multiplied by 3. What number multiplied by 3 gives us these numbers to produce 1. So 3w is equal to 45 degrees and 225 degrees. But as you can imagine, we're probably going to need more of these coterminal angles. So I'm going to keep adding a 360. 45 plus 360 is 405 degrees. And 225 plus 360 is 585. And because we have 3 omega, we're probably going to have 3 times the number of solutions. So I'm just going to keep finding more coterminal angles. So 405 plus 360 is 765. And 585 plus 360 is 945. So now I'm going to take all of these and divide by 3. So you don't necessarily have to write this step. You can just go ahead and divide. If you understand what you're doing, then that's okay. But I'm just going to write a record of my work here. So we're going to divide each one of those by, and so 45 divided by 3 is 15 degrees. And let's try to find some more room here. So we get 15 degrees, and 225 divided by 3 is 75 degrees, and 405 divided by 3 is 135 degrees. 585 divided by 3 is 195. So you can see all these numbers so far are between 0 and 360. 765 divided by 3 is 255. And 945 divided by 3 is 315. Now, if we try to find another coterminal angle, let's add 360 to 765. We get 1125. And if we try to divide that by 3, we get 375. 375 is too big, so we can just erase that. So those are our solutions. So not every problem is going to have 6 answers, so don't worry about that. They're not all going to be that involved. So let's try one more of these problems before you try one on your own. Now we have a half angle expression, half of A. So you may recognize that ratio, 2x over x root 3, that's a 30, 60, 90 degree triangle. And if secant is positive, then our triangles are in the first and the fourth quadrants. And secant is hypotenuse over adjacent, so the adjacent side must be x root 3. And the hypotenuse, of course, is 2x, and you don't have to write the other side, but the other side would be x, and the case down here would be negative x. Okay, so the reference angle has to be 30 degrees because 30 is always opposite x. So a over 2 has to be equal to 30 degrees, the first quadrant solution, or 330 degrees, the fourth quadrant solution. But in the previous problems, when we multiplied the angle by some whole number, we had more solutions than we thought we would. But in this case, because we're dividing, we're actually going to have fewer solutions than we would expect. Normally we have 2 solutions, but now we're probably going to have only 1. So we're going to have half as many solutions. So watch what happens. I'm going to multiply both sides of this equation by 2, and we get A is equal to 60 degrees and 660 degrees. But you can see 660 degrees is way too big. So we're going to X that out. That can't be one of our solutions. So A is equal to 60 degrees. That's the only solution that works in this equation. Okay, so I want you to try number 10. You can use numbers 7, 8, and 9 to help you. And when you come back, we'll do it together. Okay, we're back. So you may recognize this ratio as x root 2 over x. So the hypotenuse is always positive, so that means the opposite side, because cosecant is hypotenuse over opposite, the opposite side must be positive. So that means we have a triangle in the first quadrant and the second quadrant. And x root 2 over x is a 45, 45, 90 triangle. So the reference angle is 45 degrees. So we have one of the solutions. Not one of the solutions, but we have one of the numbers that we need, which is 45 degrees. And the other number is 135 degrees. But remember, we need to find some coterminal angles, because when you have your angle or your variable multiplied by some whole number, you're going to have more solutions than you may think. So 45 plus 360 is 405. Let's find some more coterminal angles. So we started at 45, we rotated all the way around to get to a coterminal angle, which is 405. Now we're going to start at 135, rotate all the way around until we get to another coterminal angle. So 135 plus 360 is 495. So that's probably going to be all that we need, but let's go ahead and find one more coterminal angle. 405 plus 360 is 765, just so we can rule out the idea that there's any more of those. So those are all the angles that we can plug in to the cosecant function that will give us a positive root 2 value. But we don't want the numbers that you plug in. We want to know what numbers you multiply by 2 to get these numbers that will give you a ratio that's equal to root 2. So we're going to divide both sides of this by 2. So let me copy these. So we'll divide everything by 2. And let me find some more room here. So 45 divided by 2 is 22.5. And don't be afraid to use your calculator. 135 divided by 2 is 67.5. And 405 divided by 2 is 202.5. And 495 divided by 2 is 247. And I think that's all the solutions we're going to have. But let's divide 765 by 2. And we get 382.5. So that's bigger than 360. So those are our solutions. So if you got those answers, good job. Now I want you to take a picture of these problems to help you do number 11. Be sure to get a picture with your phone. And now let's do number 11. Try number 11. When you come back, we'll do it together. Okay, we're back. So if cosine is negative, that means our triangles are going to be in the second quadrants and the third quadrants. You may recognize this ratio. It's x over 2x. So we're dealing with a 30, 60, 90 degree triangle. And cosine is adjacent over hypotenuse. So this side must be x root 3, and this side is negative x root 3. Not that we really need that side, though. So the angle opposite root 3 is always 60 degrees. So our first angle is going to be 120, and our second angle is going to be 240. But we're going to have 3 times the number of solutions that we think we're going to have. So the number that we plug in, 3 alpha, to get negative 1/2, the possible numbers are 120, 240, and 480. And just keep adding 360 to each of these numbers. So 240 plus 360 is 600. And don't be afraid to use your calculator. It's okay to use your calculator. 480 plus 360 is 840. And 600 plus 360 is 960. So that should be it. We can find one more just to be sure that we found all of them. So 960, actually 840 plus 360 is 1200. That's not going to lead us to a solution, but that's just to be sure that we found all of these. So I'm going to rewrite, and I'm going to divide all these numbers by 3. So dividing all the numbers by 3, and we get 40 degrees. And don't be afraid to use your calculator. 240 divided by 3 is 80. And 480 divided by 3 is 160. And 600 divided by 3 is 200. And 840 divided by 3 is 280. And 960 divided by 3 is 320. And 1200 divided by 3 is 400, but that is too big because we want all of our theta values to be between 0 and 360. So we can erase that. So if you got all those solutions, very, very good. Excellent. Okay, go ahead and try number 12. And when you come back, we'll do it together. All right, we're back. So you may recognize that ratio. Tangent is negative in the second quadrant or fourth quadrant. And tangent is opposite over adjacent. And so the side opposite x, or the angle opposite x is always 30 degrees. So this angle is 150 degrees, and this angle is 330 degrees. So beta over 2 is equal to 150 degrees and 330 degrees. And I'm going to rewrite and multiply both sides by 2 because we want beta. And so beta is equal to 300 degrees and 660 degrees, but you can see that 660 degrees is too big. We want the theta values that are between 0 and 360. So the only solution is 300 degrees. So if I got that right, good. If you made a few mistakes here and there, that's okay. But now you have an idea of how to do that. Okay, let's do a few more problems here. So now we're going to deal with quadrantal angle problems, and you see that the trigonometric function is not isolated. We have to get this trigonometric function by itself. It's not by itself because the negative 10 and the 2 are next to it. So we're going to add 10 to both sides. And divide both sides by 2. And you can see that we have a collapsed triangle. Tangent or cotangent can be equal to 1, but not cosecant unless we have a collapsed triangle. So we want to know the points on the cosecant red curve that have y values equal to 1. Of course, that would be here and here. So we have 90 degrees, and then if we add 360, we get to the next angle. So 2 theta can be equal to 90 degrees, and if we add 360 to that, we get to 450 degrees. Already we have a solution that's too big. This 450, it's too big. But again, we're not looking for these numbers. We're looking for those numbers divided by 2. So let's find some other solutions. Let's add 360 to 450. And let's add 360 to 810. We don't know if these are going to lead to solutions, but we'll see. Okay, so now we're going to divide everything. We're going to divide everything by 2. And so 90 divided by 2 is 45 degrees, and 450 divided by 2 is 225 degrees. 810 divided by 2 is 405 degrees, and you can see that those are not solutions. 1170 divided by 2 is 585. Those solutions are too big, so we're going to get rid of those. So our final solutions are 45 degrees and 225 degrees. So the difference with that problem is that we had a quadrantal set of angles, 90, 45, 810, 1170, but our answers were not quadrantal angles. We just had to use those quadrantal angles to find our answers. Okay, let's try another one of these. So now we have trigonometric functions on both sides, but those functions are the same. We have like terms, so I'm going to subtract cosine x over 2 from both sides. 5 cosine x over 2 minus 1 cosine x over 2. 5 cosine x over 2 minus 1 cosine x over 2 is 4 cosine x over 2. And then I'm going to subtract 4 from both sides, and I'm going to divide both sides by 4, and you can see that this is going to be a collapsed triangle. So we need to know when is cosine -1, so we have to go to our curve. When you have a collapsed triangle, you want to use these curves. So cosine is -1 at 180, and if you want to find any other values, you just add 360 to get to the next one. So 180. But I don't think we need any more angles. If you multiply both sides of that equation by 2, and maybe I should write those other angles just so you can get a feel for what's happening here. 180 plus 360 is 540, and 540 plus 360 is 900. But again, these are not going to give us answers that we want. But I'm going to multiply both sides of the equation by 2, and we have x is equal to 360 and 1080 and 1800. But again, these are not solutions because they're not between 0 and 360. Now we are allowed to have solutions that are equal to 360, so there you go. X is equal to 360 degrees. So I want you to take a picture of these problems. You're going to need these to help you do the next problems. And attempt number 15, and when you come back, we'll do it together. Alright, we're back. I'm going to add 7 sine 3a to both sides. 8 sine 3a plus 7 sine 3a is 15 sine 3a. And I'm going to subtract 17 from both sides. Well, maybe I'll show that step. So I'm going to subtract 17 from both sides, and then I get negative 15 on the left side of the equation. And then I'm going to divide 15 by both sides. And again, we can see that we have a collapsed triangle because sine is equal to -1. So now we go to our sine curve. Whenever we have a collapsed triangle, we look at these curves. Sine is -1 at 270 degrees. And then to get to the next value, you just add or subtract 360. So 270 is the angle that you plug into the sine function to find your answer. But it looks like we're going to need some more coterminal angles, because remember, if we're multiplying a by 3, we're going to have 3 times as many solutions as we think. So 630, add 360 again, and you get 990, and we'll just add one more just in case. So just adding 360 each time. And now we're going to take all of that and divide by 3. And so 270 divided by 3 is 90. And 630 divided by 3 is 210. And 990 divided by 3 is 330. And 1350 divided by 3 is 450. But that is not going to be a solution. So our final answers are 90 degrees, 210 degrees, and 330 degrees. So if you got those answers, perfect. Okay, so go ahead and try number 16. You're going to have half as many solutions as you think, because we have a half angle expression. Try 16. When you come back, we'll do it together. Okay, we're back. I'm going to subtract 1 from both sides, and I'm going to divide both sides by 3. And when cotangent is 0, again, we have a collapsed triangle. So let's go to the cotangent curve. And what are all the points on the cotangent curve that have y values that are equal to 0? We have this point, and this point, and this point, and this point, and this point. So it looks like we could start at 90 and add 180, or subtract 180. Subtract 180 or add 180 to get to the next values. So 90 plus multiples of 180. So b over 2 can be 90. And if we add 180, we get 270. And we can see immediately that we're not going to have any more solutions, because when you multiply by 2, the numbers are going to get too big. So I'm going to multiply both sides by 2. And so b is equal to 180 degrees and 540, but that is not a solution because it's too big. We need solutions between 0 and 360. So we get 180 degrees. Have you got that one right? Perfect. Okay, so let's just do a couple more problems here. We got 4 more problems. These are just some other varieties. You may recognize that ratio, root 3. So we're just doing the exact type of problem, except we have a more complicated expression in here. So if tangent is root 3, that's positive, so we're in the first quadrant or the third quadrant, and tangent is opposite over adjacent. So the angle opposite root x root 3 is always 60, so our reference angles are 60 degrees. So one solution is 60 and the other is 240 degrees. So what that means is that 3 omega plus 90 is equal to 60 degrees or 240 degrees. But I think we need to find some other numbers just to be safe. So 60 plus 360 is 420, so we're finding coterminal angles. 240 plus 360 is 600. And 420 plus 360 is 780. And 600 plus 360 is 960, so hopefully that'll be enough. So what I'm going to do is we need omega. So I'm going to subtract 90 from all these numbers. And you don't have to write minus 90 for each one of these numbers. That's going to be too much work. So I'm going to write an expression that's not exactly mathematically correct, but it's enough so that you know what's going on here. So now we have 3 omega is equal to, what is 60 minus 90? That's going to be negative 30. So that's definitely not a, well, we'll see what happens. And then 240 minus 90 is 150. 420 minus 90 is 330. 600 minus 90 is 510. And 780 minus 90 is 690. And 960 minus 90 is 870. So now we're going to divide each of these by 3, so we get negative 10 degrees. That's not a solution. 50 degrees, 110 degrees, and 170 degrees, and 230 degrees, and 870 divided by 3 is 290. So it looks like we might actually have more solutions. Looks like one more solution. So you can verify all this for yourself. So let's find another coterminal angle. We're going to add 360 to 780. And we get 1140. 1140. And we'll subtract 90 from that. And we get 1050. And then if we divide that by 3, we get 350. So we just made it in our interval. And negative 10 is not a solution. Now you don't have to keep rewriting all this. In fact, you don't have to write any of this. You can actually just write, maybe I want you to write this step, and you can do the rest in your head. So don't be discouraged. There, I'm writing all this, so I'm going to cross out that negative 10. So not all of these problems are going to have so many solutions. Okay, let's do another one of these. So cosecant is equal to negative 1. So that's a collapsed triangle. So we need to go to our cosecant curve and find all the points on the red curve where the y value is negative 1. So that's here and here. So 270 and negative 90 degrees are the corresponding angles. So theta over 2 minus 180 is equal to 270. Now here's where we need to stop and really think about this. When you, well, first of all, we're looking for the theta between 0 and 360, right? When you add 180, that's going to convert a negative angle. We don't know for sure, but it might convert a negative angle that you can plug in here to get negative 1. It might convert a negative angle to a positive, which means that we actually need to consider negative 90. In previous problems, we haven't had to do that. Now again, if you go to your cosecant curve, we have 270 and we have negative 90. And if we subtract notice there's 1, 2, 3, 4. So that's 360 degrees between the numbers. So I'm going to go ahead and subtract 360 from negative 90. And then we get negative 450. So I'm going to find an extra negative angle there. We don't really need that angle, but we're just demonstrating the principle here. So now let's add 180 to both sides. So if we do that, we get theta over 2 is equal to, and you can use your calculator if you want, negative 450 plus 180 is negative 270. So that is probably not going to give us, it's not going to lead us to a solution, but we'll just keep that number. But notice that this number is going to give us a solution. So this is the first time that we've had to write a negative angle. If we add 180 to negative 90, we get positive 90. So that is possibly going to lead us to a solution. So you really have to be careful. Sometimes you have to actually find a negative angle when you're subtracting something, because when you add it on the other side, it might change a negative angle to a positive angle. So that would be included in the interval between 0 and 360, the result of all that. So now we're going to add 180 to 270, and you can see that that's probably going to be a number that's way too big. 450 degrees. Okay, so now we are going to multiply both sides by 2, and negative 270 times 2 is 540, so that would be negative 540. So that does not lead us to an answer, because that's theta has to be between 0 and 360. Then we get 180. That is going to be an answer, because that's between 0 and 360, and 450 times 2 is 900. That's not going to lead us to an answer. So the whole point here is that we had to actually find a negative angle that we could a negative angle up here that we could plug in to give us negative 1, because once we add 180, we get a positive number. So be careful with that when you're adding or adding or subtracting something to your angle or your numbers. Then you might get you might end up converting a negative to a positive. So that's kind of tricky. Okay, so I want you to try number 19, and when you come back, we'll do it together. Okay, we're back. So we have a collapsed triangle here when tangent is 0. So it looks like our answers are going to be multiples of 180. 0, 180, 360, so on and so forth. So we have beta over 2 plus 60 degrees is equal to 0 degrees, 180, 360, and so on and so forth. Now, do we need a negative angle? Probably not, because when we subtract 60, that's just going to make it a bigger negative. So we don't really need any more numbers. So now let's subtract 60 from both sides, and we get beta over 2 is equal to negative 60 and 120 degrees and 300 degrees. And so then we're going to multiply both sides of the equation by 2. So we have beta is equal to negative 120, 240, and 600. So you can see that there's only one solution. We can't have a negative number. We can't have a number bigger than 360. So beta is equal to 240 degrees. So we got that one right. Excellent. Okay, so you can take a picture of these if you want to help you with number 20. Go ahead and try number 20, and be aware that because you have a minus 270 here, you're going to have to find some negative angles that you can plug in here to get root 2. So there's a possibility you may miss some solutions if you don't consider the negative angles you can plug in to the secant function to give you root 2. When you look at your axes and your reference triangles, you need to go in the negative clockwise direction. So if you're not sure what we mean, go ahead and do the problem, and then you can we'll figure out if you miss some solutions. So try number 20. When you come back, we'll do it together. Okay, we're back. You can probably recognize this as x root 2 over x, which means we have a 45, 45, 90 triangle, reference triangle. And secant is positive, which means that our triangles are in the first and fourth quadrants. And of course the hypotenuse is x root 2. And we have x and negative x. And the reference angle, of course, is 45 degrees. So 2 alpha minus 270 can be equal to 45 degrees, and this angle here is 315 degrees. But the problem is, once we add 270, we're going to change a negative angle into a positive. So we need to find some negative angles that we can plug into this function to give us root 2. So this angle is 315, but what if you go in the clockwise direction? Clockwise is negative. We went all the way around 315 degrees counterclockwise. That's a positive angle measure. 315 degrees counterclockwise. But what if we go 45 degrees clockwise? That's a coterminal angle. So we need negative 45 degrees. And what if we go a little more? Let's find a coterminal angle for the first quadrant that's negative. So we're going to start at the positive x-axis, and we're going to rotate clockwise. And what do we get? We get negative 315. So we need negative 315, but I don't know if that's going to lead us to a solution. Actually, we can see it's actually not going to lead us to a solution. So I think those are all the numbers that we'll use for now. So now let's add 270 to both sides. So we get 2 alpha is equal to positive or negative 45 degrees. So that is not going to lead us to a solution, because it's going to end up being negative when you divide by 2. Negative 45 plus 270 is 225, and positive 45 plus 270 is 315, and 315 plus 270 is 585. And now that I think about it, there might be some more solutions. There might be some other numbers that we can find. So I'm going to move this over. And what else can we find? Let's add 360 to 45, and we get 405. So if we add 270 to 405, we get 675. So maybe we'll just leave it there. Okay, so now let's divide everything by 2, and we get negative 22.5 degrees, which is not a solution. So you can see that one of these angles is not going to be a solution. So the final answers are 112.5 degrees, 157.5 degrees. So if you got those solutions, good job. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3, number 4, 5, 6, 7, 8, and 9. But don't go before you get your homework. Here's the homework. Screenshot number 1 and number 2 and number 3 and number 4. Remember, if you don't do that homework, it's a 100% chance, it's a 100% guarantee that you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.